Trigonometry. Good morning. Welcome to TMMS Productions. In this video, we are going to learn how to solve the trigonometrical identities. That's a little advanced in part 2.
We continue with our trigonometrical identities. Now, the identities are the relations between the various trigonometrical ratios which hold true at all times. And so, today in this video, we are going to see some simple identities like I have written over here. First one, prove cos theta upon 1 plus sin theta plus 1 plus sin theta upon cos theta is equal to 2 sec theta. Now, in order to solve this, we need to know the basic identities. That is the relation between the squares of the ratios. So first one being sin square theta plus cos square theta equal to 1. Second one, 1 plus tan square theta equal to sec square theta. The third one, 1 plus cot square theta equal to cosec square theta. Now, apart from that, you need to know the inverse ratios like 1 upon sin theta, equal to cosec theta. 1 upon cos theta is equal to sec theta. 1 upon tan theta is cot theta, and sin theta upon cos theta equal to tan theta. Now, this I have already done in the part 1. Since this is a part 2, we will now use these in order to solve this. Now, the first technique is that you start either with left hand side or right hand side, whichever is more complex, and all you have to do is simplify. And so here you can see that our left hand side is more complex. Let us start therefore with left hand side. So we'll write LHS. Now first step is to copy our left hand side. Next step is to start simplifying it. Now when we simplify, what are we looking for? We are looking for making this into a one term. Now there are two terms over here, both the terms are fractions. So we have to take LCM. So 1 plus sin theta, this will be multiplied by cos theta. And so cos theta will multiply here. It becomes cos square theta plus 1 plus sin theta will multiply here. Now 1 plus sin theta, 1 plus sin theta. If you multiply, we get 1 plus sin theta whole square. What would we do after this? Denominator we will write as cos theta into 1 plus sin theta. And for the numerator, the first term we will keep as it is, and here we will use a plus b whole square. That will be a square plus b square plus 2ab. So we will write 1 square plus sine square and plus 2ab, that is 2 into 1 into sine theta, that is 2 sine theta. Now, are you able to see this and this? Can you see this identity over here? Sine square theta plus cos square theta is equal to 1. So what would we do? We would write in place of sine square theta plus cos square theta 1. So 1 plus 1 plus 2 sine theta. And the denominator will remain as it is. Now, 1 plus 1 is 2. So 2 plus 2 sine theta, which means 2 into bracket 1 plus sine theta, correct? And upon cos theta into bracket 1 plus sine theta. Now, can you see this common factor? And so you will have 2 multiplied by 1 upon cos theta. Now 2 into 1 upon cos theta, look over here, 1 upon cos theta is sec theta. And so we will get sec theta in place of 1 upon cos theta, and this 2 over here, and that will give us our right hand side, and we say hence proved. Now this was one of the simpler ones. Now slowly and gradually we'll take a little more complex ones. Let us come to our question 2. We have to prove that 1 plus cos theta upon 1 minus cos theta is equal to sec theta plus 1 upon sec theta minus 1. Now here we are going to start with LHS, and we are going to look at this cos, and our cos, if it is made the reciprocal of it, it becomes sec theta. So we will write 1 plus cos theta as 1 plus 1 upon sec theta. Why would we do that? Because we have to bring sec theta. We have to go towards the right hand side. Right hand side has got sec theta. And so we will start by using LHS equal to 1 plus cos theta upon 1 minus cos theta, and that is equal to 1 plus cos in terms of sec. So it will be 1 upon sec theta. And in the denominator 1 minus 1 upon sec theta. Now can you see there is fraction in the numerator and fraction in the denominator. So be very careful as you write this. Main numerator denominator line should be big enough. And then we are going to simplify this. So simplifying means we'll have to take the LCM. So we take the LCM as sec theta, and now sec theta will be multiplying here because this is 1. 1 becomes sec theta upon sec theta, right? So we will write here sec theta plus 1. And here again in the denominator, we'll take LCM, which is again sec theta. This 1 becomes 1 upon 1 means sec theta upon sec theta, we can write it. And so we will write here as sec theta minus 1. Now what do? We have a fraction here, we have a fraction here in the numerator and denominator. So in order to simplify, we will write sec theta plus 1 upon sec theta, and now this is dividing this fraction, and so we will multiply by its reciprocal, that is sec theta upon sec theta minus 1. And so sec theta gets cancelled. Can you see we are going towards this? So that will be equal to sec theta plus 1 upon sec theta minus 1, which is our RHS. And we can say, yes, we have proved it. Now, some of you will say that you have taken LHS. Can we take RHS also? So the answer is yes. And so let us take another method, and I'll call this as OR. And here I will start with RHS. So if I take RHS, I will write first sec theta plus 1 upon sec theta minus 1, which means if I have to simplify this, I should look for cos. So sec is 1 upon cos. So in place of sec, I will write 1 upon cos theta plus 1. And here I'll write 1 upon cos theta minus 1. Then we'll do exactly the same thing as we did here, except that here it was 1 upon sec theta, and here we've got it as 1 upon cos theta. So now when you are taking the LCM, in the numerator you'll get 1 plus cos theta, and here in the denominator I'll take again cos theta as the LCM, and I will get 1 minus cos theta. Now what do? I will write 1 plus cos theta upon cos theta multiplied by cos theta upon 1 minus cos theta. And so you will see that cos theta got cancelled, and 1 plus cos theta upon 1 minus cos theta, and that is our LHS, and hence we proved what we had to prove, that RHS is equal to LHS. So you see that there is no hard and fast rule that you have to start with left hand side only. You could start with right hand side as well. As long as you work it out to be equal to the other side, you will be absolutely logical and right. Sometimes what happens is that you solve LHS and you come up to a point, after that we cannot proceed. So we just leave it at that. We call that as statement 1. Then we take the RHS and we solve it and we come to the same result. So if LHS gives the same result, RHS also gives the same result. That means LHS and RHS are equal. So this is the way we have to start proving the identities. Lots of children don't like this because they do not know which method to follow. What if I forget the method? But not to worry. Just start simplifying, and you must know your basic ratios. That is this what I put in front of you. These ones you should know by heart. Okay, so let us come to question number 3. We have to prove that under root 1 minus cos theta upon 1 plus cos theta is equal to cosec theta minus cot theta. Now a whole lot of children get worried when they see this under root sign. But get this clear, if there is under root over here, this must be the square of something. Why would we say that? Because on the right hand side there is no square, which means the square root is taken, which means that whatever is under this under root sign, that must be a square. But how do we get rid of the square root sign? So what we do is we take this square root sign, and under that square root sign we will write what was given to us, and we will multiply and divide by 1, which means I am going to take now 1 minus cos theta upon 1 minus cos theta, kind of rationalizing the denominator. Now what we are going to do is we are looking at the right hand side. Right hand side is cosec theta, which is 1 upon sin theta, minus cot theta is cos theta upon sin theta. Now, because we see in the denominator sin theta, I'm trying to get sin theta in the denominator. Now this is 1 plus cos theta. If I multiply this with 1 minus cos theta, then I'll get 1 minus cos square theta. Now what is 1 minus cos square theta? Just look at this where I put all the identities together. What was our first identity? Sin square theta plus cos square theta equal to 1. And so if we take cos square that side, we'll get 1 minus cos square theta, which will be equal to sin square theta. And if I take sin square theta that side, I'll get 1 minus sin square theta. And here cos square theta will remain, so 1 minus sin square is equal to cos square. So I have done that for each identity like this. Now as and when I require this, I will use it in my proof. So let us see what we can do. So under root, this root sign is still there, and here we will write 1 plus cos theta into 1 minus cos theta would give us 1 minus cos square theta. How do we get this? By simply using a plus b into a minus b gives us a square minus b square. This we've done in the earlier classes. Now in the numerator it will be 1 minus cos theta whole square. Now what we have to do is we have to get sine in the denominator. So look at this, 1 minus cos square is sine square. Can you see that? Here. And so I will write under root 1 minus cos theta whole square upon sine square theta. Correct? So now what we will get is the square in the numerator, the square in the denominator, and so we will be able to take the square root of the numerator, giving us 1 minus cos theta, and denominator is sine square theta, for which the square root will be only sine theta. Now keep looking over here. What is our right hand side? It is not one term like how we got over here. It is two terms. So what we do is we split as 1 upon sine theta minus cos theta upon sine theta. And that would give us 1 upon sine theta as cosec theta minus cot is cos upon sine. Can you see that we got cos theta upon sine theta, which is cot theta, and so we have got this, which is our RHS. Now when it is our RHS, we have proved what we had to prove, and so we write hence proved. So these were some of the samples of the easy and the simple trigonometrical identities. Hope we have understood all the skills and all the methods that I've explained here. Thank you for watching.